Okay, so it's 5 o'clock. We're going to get started. My name is Jake Williams. I work with a CSR group. This is DropSmack, how cloud synchronization services render your corporate firewall worthless. So Black Hat requires us to actually tell you to please complete the speaker feedback because they care, right? And I'm sure they really do. So please complete the speaker feedback surveys. So why trust me, right? Well, I've got more than a decade of work in systems engineering, malware reverse engineering, most importantly forensics. I'm doing a lot of PhD level research, looking at techniques for botnet detection. Won the DC3 forensics challenge twice in a row. Rock on, love DC3. Last summer I had the opportunity to develop develop a course on cloud forensics. Wow. This is a wide open field as far as the forensics and security of our cloud providers, and it's amazing how many people are moving to the cloud for security, and I think it's just the opposite. I've had a lot of time to research this. I'm working with SANS right now. We're redeveloping, I guess, a much larger course that won't be internal. Hopefully that'll come out this summer, so if you're interested in cloud forensics, stick on the SANS website. What's this going to be about? Well, in case you're in the wrong room, Dan Kaminsky is probably speaking somewhere else right now. I was told he's not at this conference, but usually it seems like every Black Hat he's speaking somewhere, and with my luck he'd be opposite me. But really we're going to look at cloud synchronization services like Dropbox. Basically when I look at a synchronization service, I'm talking about anything where you drop a file on a machine, it uploads to the cloud, and that automatically synchronizes to other devices. Sounds like a great user convenience thing. But not so much. I mean, it introduces its own security risks. So we're going to talk about how to use Dropbox to own a protected corporate network, completely bypassing the network defenses. And I'll introduce some malware or pen testing tool, depending on which side of the fence you sit on. You could use it as a pen testing tool. Certainly it can be a framework for malware, although from a legal standpoint, I'm not suggesting that anybody uses for malware or exfiltration. And then we'll look at some potential ideas of how to stop somebody from doing it to you. So, big disclaimer, because I really don't want to get sued. Really don't want to get sued. I'm picking on Dropbox in this research. The proof of concept implant or malware code pen testing tool, whatever you want to call it, it uses Dropbox. We're picking on Dropbox because of the Coca-Cola of file synchronization services, right? I could talk to you about Spider Oak, I could talk to you about Box.net, or any number of dozens of other cloud synchronization providers, but by a long shot, Dropbox is the most common. Dropbox is providing a command and control channel by design. This isn't something that Dropbox can go fix. By design, when you install Dropbox, you are creating a channel. It's exactly what you want it to do. It synchronizes files to the cloud and then ultimately back to any other device you have configured on the account. It just does it. Anything that I'm demoing here with Dropbox can be done much more easily to every other product that I tested. So I'll talk a little bit more about why Dropbox is a little bit more secure actually than some of the others. Basically the point here being that this is the most secure by a long shot. Right? So it's only easier for any other synchronization service that we tested. I am not releasing a zero-day attack here. I cannot stress that strongly enough. Not releasing a zero-day attack here. I'm sure that somebody somewhere is going to blog that indeed, some guy hacked Dropbox. Yay, right? 0-day in Dropbox. I see the guy in the front row taking it on right now. I appreciate it. Thank you, sir. So, cloud synchronization, right? It applies more than just online backup. You place a file in a folder on any participating machine, it gets synchronized to all machines via the cloud, right? We're playing buzzword bingo, by the way, too. Right? When I get 5 buzzwords in here, somebody yell bingo. All right, so infecting files destined for a backup site, I think that would be really interesting, too. We're not getting command and control from that, but you start thinking about cloud backup, and this is something that I've been thinking a lot about here. If I'm a long-term adversary, right, APT, right, that's 2 for 5, right, for anybody who's counting buzzwords there, but you think about APT, they want to get into that backup solution. It shouldn't be a big secret, right, that they want to get into the backup solution so that when you restore the machine, they already have infected files sitting on the backup solution, PDFs, documents, you name it. Again, it would be great to get repeat infections from any given single attack. We're not going to be able to get command and control from that. But as far as long-term thought processes, that's something that I'm looking at as far as how would we defend against it. I mean, I'm certainly not APT. I would be standing up here going, hey, what I'm looking at is ways to But really, I think we need to think about how would we detect that, short of statically scanning our files, and I think we all know that's not going to work. We're going to use antivirus. Right. So Dropbox and their history of insecurity, right? And again, I'm picking on Dropbox because they've gotten the most press. Again, they're the Coca-Cola of file synchronization service. I'm not saying Dropbox authentication is horribly broken, but indeed several people did in 2011. We'll talk a little bit more about that later. Dropbox had an awesome no password day in 2011. I don't know if any of you guys saw this, but it was like free beer, right? And so for somewhere in the neighborhood of 2 or 3 hours, Dropbox didn't require a password at all. If you knew the unique ID of the user, that not necessarily their email, but Dropbox has a unique ID that does not change per user, you could access that user's account and download or upload files. Now, of course, Dropbox in their wonderful PR campaign wrote a blog post and said, hey, we're going to be more careful about the way we commit code from now on, because when we roll that out, that can be dangerous. And so essentially they blamed it on some insecure piece of code that they had pushed out globally, and they said they fixed it within hours, and anybody that had any accounts with any anomalous activity was contacted immediately, and so there was no actual damage from the compromise. Right, okay. I have awesome beachfront property in Arizona that I'm more than willing to sell anybody here if you believe that one too. So how about mobile file metadata? So Dropbox, even though they transmit your files securely, just like all these file synchronization services do over HTTPS, for whatever reason, on their mobile application, because you can synchronize your files to your iPhone, to your Android, for whatever reason, their mobile application was sending all of the file metadata over HTTP rather than HTTPS. That was discovered back in 2011. So now if you picture these wireless hotspots like a good old Starbucks or airport, and now you're getting synchronization. And mind you, this doesn't have to start from the actual mobile device. Right? If this is the first time your mobile device is connected since you've synchronized something off of your laptop or your work PC or whatever the case is, it's up in the cloud, but you don't have the most current version of it. All of that metadata now is synchronizing back down, and it's in the clear to see. Again, Dropbox has obviously fixed that. Why aren't there any other products up here? Turns out nobody's looking at the lower tier providers. Not that I can find anyway. We've been looking a lot at these, much more to come on the insecurity of file synchronization and some of the awesome things that you can do with it. But for this, we had some foundational work. So I have a pen testing background, and as I started doing this cloud forensics course, I thought, hey, it's really bad, especially in companies that are employing MRTG or some type of bandwidth monitoring. I really don't want a spike coming back to whatever my bandwidth spike, coming back to whatever my command and control / exfiltration server is. I was thinking I would like to use Dropbox. Maybe I can surreptitiously install Dropbox, in this case, or some other synchronization service, something that uses Amazon S3, and we can just exfiltrate stuff out to, out to that. Then it looks like it's traffic destined for S3, not spiking on my command and control server. And started looking a little bit more of that, and it turns out it wasn't that original of an idea. So several guys at a Usenix conference published the Dark Clouds on the Horizon paper. They talked about the idea of using the file synchronization software for covert data exfiltration. They talked about a lot of other neat things too from a pen testing standpoint, so I strongly recommend you grab the paper. It's out on the Usenix website. A couple of guys named Frank McLean and Derek Newton then followed up, and these are the guys actually that said Dropbox authentication is horribly broken, right? Their words, not mine. Apparently they independently researched this stuff, as far as I can tell. They talked about the database format, and they published all of the details. So on the back end, Dropbox and most of these other file synchronization services use a SQLite database to track which files have been synchronized, which files haven't, even MD5 sums of the files. In some cases, for very large files, they even break up the file and give you section hashes for each, say, 200K of the file. From a forensic standpoint, I mean, this is a gold mine, right? If you're thinking about it from a pen test standpoint, you can certainly, certainly can imagine if you've got a hold of this particular database, maybe you have hashed creds. I'll take the maybe out of there. You have hashed creds, right? And so now maybe you have a way to access the user's account without still having access to that machine. So they published the details, and Dropbox promptly changed them. I mean, like immediately changed them. So a couple of guys here, Ruff and Ledoux, reverse engineered in 2012. They reverse engineered the Dropbox software to look at security. So under the hood, Dropbox uses Python, so essentially a compiled Python, but they build their own Python interpreter. This is pretty sneaky, and so they're not the first people to do this, but they build their own Python interpreter, and they mash up all the Python opcodes. And basically it's to prevent you from decompiling the Python essentially and looking at the original or trying to get back to the original Python source. They actually go a little bit further though. Not only do they mash up all the opcodes, because that's even fairly easy to get around, they actually change all of the marshalling format in the Python library, so you can't even unmarshal the code directly to review the opcodes. It's a real pain in the butt. These guys, Ruff and Ledoux, did some awesome work, reverse engineered the Dropbox, basically the Dropbox software. They published some of the internal details of how the database was now being built, because Dropbox took the extraordinary step of encrypting, and they actually are encrypting with a commercial encryption library, encrypting the databases after the earlier work. And so they reverse engineered it, and they said, hey, here's how to decrypt these, here's how to steal the hashed credentials out so you can go on doing what we were doing before. And I mean, within weeks, Dropbox changed all the internal details, and I'm fairly confident that even if I publish details today, I'm not, but that if I do today, they will change them immediately again. In fact, even by me just being up here talking about some of the internals, it won't surprise me at all if they, again, change it again. So long term, I mean, this is really just going to become a cat and mouse game if somebody wants to get into their database. Ultimately, as we're all aware, right, if they're encrypting it and the user's not typing the password when he logs in, right, it's freely available. It's just not, it's encrypted basically when it's sitting at rest on the file system. So let's talk a little bit about a little case study. So we've got this client, Massive Dynamic. Any of you guys Fringe fans out there? No, Fringe? Yeah, there we go. So good old Massive Dynamic, right? And so, because I have to pick some company. And basically they say no holds barred pen test. Act like APT, right? So no problem, we got that covered. Look at a long engagement time, but a completely black box, right? So you can call this a pen test, or you can look at this almost like the way I believe intrusions are probably happening today, right? So look at standard methods, right? They fail. Web portals, yeah, no go, right? Outdated patches on public servers, again, nothing. Social engineering, yeah, maybe you get some basic IT info, but we all know the deal, right? I mean, social engineering works a lot, and then, oftentimes it gets cut short by these wonderful employees who inform security, and then everybody's on alert, right? And so if you've got time to wait for that alert to go down, great. If not, find something else. You want to go to physical security? This guy scares me, right? So if you've got awesome armed security someplace, don't go and try to do pen testing there, right? This guy looks way, way too jumpy. As far as doing physical pen testing, I love to jump the front counter, steal the drive, grab the credentials and get on the domain. But again, that's not going to work in this case. How about spam, right? So again, another thing we often try when we're doing pen testing, you look at spam, maybe get some quick hits. Right, in this scenario, we'll say we got some quick hits. By the way, I love this little stop the spam or we'll shoot the dog, right? But in some cases, and I've had this in a lot of my real world pen tests, I'll get some connections back, but there's a decent content filtering firewall in place. So I'm seeing people click the link. I've got stuff in the web logs, but anytime I actually try to send the exploit down, I'm getting stopped. I never get a call back from the exploit. Right, so there's something in the network, and so let's just start from that assumption. There's something in the network that prevents us, right, from actually getting a solid TCP connection, command and control. Maybe, again, maybe we can get something via, via them clicking the link, but again, ultimately that's not sustainable, right? So time for Plan B, right? Nope, not that Plan B. $25 in a college campus vending machine. They're not getting us out of any like hardcore mess, right? So how about this guy? Well, it's not very uncommon. You start up and you look for your traveling salesman. If you guys have done pen testing before, you look for the traveling salesman, the guys that are outside of corporate network security. Guys, and also guys that are going to have VPN access, right? Because in some corporations, not everybody has the VPN access. So in this case, we're looking for this guy. We find this guy's personal email address because he's the CIO or whoever. By the way, I love hitting the CIO and the CSO if you get a chance to hit anybody, because they're the guys ultimately that are preaching security left and right. Of all the people, they're the best by a long shot to hit, because then they don't argue their pen test results. So we look at Facebook, says, hey, he's organizing fundraising for his kids' PTA. I love exploiting somebody's kids to own a target too. I mean, call me ruthless, call me bad, but again, it's wonderful stuff. So suppose that we spam him at home, right? So we go after again, looking at his home machine, own the laptop. Start looking for VPN software, because that's what we do next, right? We're on his laptop at home. We know this guy doesn't get to be a CIO, right? Again, by not working, 18 hours a day, whatever the case is. But we find confidential corporate documents on a laptop. Okay? Clearly these aren't moving by USB. Nobody's that dumb anymore. I'm sure everybody has DLP solutions in place on every major, oh wait, no. So anyway, we've got the confidential corporate documents on the laptop. They have to be getting there somehow. And then we notice that all the company documents are in the Dropbox folder. And Dropbox.exe is in the process list. Again, picture, we're on the laptop, we're outside of the corporate network. Right? I get into more corporate networks this way from a pen testing standpoint than probably any other way. Again, if they've got awesome defenses, you hook them up at the hotel or where they're staying at, if it's a road warrior, or you catch them at home, again, ultimately you're back into the corporate network. Now we're getting somewhere. So we pull the Dropbox databases, see what we can see. Databases are encrypted. We could reverse engineer the Dropbox software to read the databases, grab his credentials, see what's even being stored out on the website, because Dropbox backs everything up to the web as well, or maybe we could mimic his machine, but
ain't nobody got time for that.
And so I don't know if any of you guys have seen this before, but that's good old Sweet Brown. And if you haven't seen that before, and she says, ain't nobody got time for that, there's a whole 45-second, I don't have time to play it here, but a whole 45-second awesome, man, for lack of any better word, interview, I guess. It was actually a news interview, and it's called Sweet Brown's Cold Pop Escape. So again, it's well worth your time. I'm sure from a bandwidth standpoint, it'll never download here, but awesome. So where are we? Well, what do we have so far? We have a way to send files over Dropbox to devices the CIO uses, right? Or whoever the laptop owner is. In this case, again, he's our CIO. We have a way to send those files over Dropbox, and it's going to synchronize to every device this guy uses. What we would really like to have is a running implant, malware, whatever it is that you call it, with command and control inside the corporate network. We want to be able to execute commands and exfiltrate data from inside the corporate network. Right? So it's time to brainstorm, and I brainstorm best with a little inebriation. No, lots of beer. And notice this guy is smiling, and I would be too if I had cases upon cases of beer behind me. So with a blood alcohol level, it's a little bit high. By the way, what company was it that was giving out the breathalyzers here? That was a brilliant, brilliant little swag gift there. But ultimately, figure out the Dropbox. We can use his existing Dropbox software to infect the internal network and the RC2 channel. So this only works if the CIO has Dropbox installed on his corporate machine behind the firewall. We have confidential corporate documents though. We've got those in his Dropbox synchronization folder. That's a pretty good assumption then that he has Dropbox installed on the corporate network. In fact, that's our working theory of how these documents got onto the laptop in the first place. So what we really need to do is write some new malware or a pen testing tool or whatever the lawyers prefer that we call this so that I don't get sued, right? And so we could just deliver a standalone interpreter via Dropbox. We could infect a file, send a standalone interpreter, but let's not forget, we tried standard approaches first, and nothing else that we delivered has been able to call out of the network. And so delivering a standalone interpreter that creates a TCP connection out of the network probably isn't going to work here either. What we need is malware that can use Dropbox, basically the Dropbox file sync service, instead of traditional network-based C2. Kind of like spies using a dead drop. A drop, yes, I definitely intend the pun there, right? So we created some little malware called DropSmack, and it's proof of concept malware. It's designed to use file synchronization by Dropbox for command and control. It's not really fast, but Dropbox is getting better every day. So when I put this together about 4 months ago, my average turnaround time, so say I'm pen testing, out of Georgia where I live, pen testing a client in Maryland, which is a fairly common occurrence, we had synchronization time somewhere on the order of 1 to 2 minutes. And today, tried it out, and I'm going from Amsterdam back to the States, VPNing into a machine back there we have for test, and I had synchronization times on the order of 30 seconds or less. And so this is getting faster and faster and faster, almost to the point where we might be able to tunnel a connection somehow through, through here. And we're looking at that as future research. So even without tunneling connections, though, we can certainly do store and forward. Data exfiltration and command output, they're sent by Dropbox synchronization. Again, exfil isn't that fast, but Dropbox is making it faster and faster and faster, and I love them for it, right? So again, I want to give mad props to the Dropbox development team. From a synchronization standpoint, they're definitely the fastest. So again, they're encrypting their databases, good for them, and they're making exfiltration awesomely fast. Again, good for them. I mean service, not exfiltration, awesomely fast. So how does this work? Well, if you prefer a picture, basically we've got the guy's laptop at home. and that's the local Dropbox share. We've got our Dropbox server, which we don't control and we don't need to control. Again, this is insecure, or however you want to word it, by design. And then we have a remote Dropbox share. Again, picture this inside the corporate network with all their wonderful defenses. And again, this is basically anything that we synchronize or place on the user laptop at home. And again, realize that because this is behind a Soho router, we have a full TCP connection in this case. So we have no problems at all controlling this machine at will. Anything that we synchronize here is ultimately going to copy over onto his workstation at work. So would I use this for long-term use? Not really, right? I would prefer not to use this long-term, but once you have bidirectional command and control, you're no longer shooting in the dark. I mean, that's one of the hardest things when you have some defenses in the pen test is figuring out what those defenses are. I mean, picture the case where you're able to go to the machine, sit down, start typing on the machine, and troubleshoot why your stuff doesn't work, right? It just moves that much faster. And this is ultimately what that gives you. It gives you a chance to infiltrate the data and exfiltrate, basically query the box on the other side of the Dropbox server, and ultimately get answers back. And that allows you to troubleshoot and hopefully then leave this entirely behind, right? Again, I would not want to use this for long-term use. I couldn't be any clearer about that. But again, anytime you're able to observe results from failures, that is a huge, huge help. And we know that this guy gets traffic out of the network. Dropbox is getting out of the network. It's just a matter of finding out what those defenses are and how traffic leaves the network, right? Usually when I get blocked in one of these cases, I later find out that there's a proxy someplace and we're just not pointing at the proxy, right? So, or some type of authenticating proxy, whatever the case is. So put together a small implant. Again, it implements some really, really basic commands. Put, get, delete, execute, sleep, and move. We looked at adding more, but this combination gets you everywhere that you need to go. I mean, there's basically, at the point that you have put, get, and execute, you've got the full super set of commands. You can build everything else with that. The other stuff's just convenience, because I got tired of running a command to either move a file, delete a file, or hang on for a minute to do tasking. So how do you deploy this thing? Well, I can't do everything for you. It turns out that there are some pretty general steps. The first one is that I usually embed DropSmack. We've used this in the pen test that we've done it on. We'll embed DropSmack in a file that the victim has already synchronized. This has a tremendous advantage because the user thinks they wrote the document, right? So again, try and let it sink in for a minute. It's not like you're sending the user a document where you say, okay, well, hopefully they'll buy that the return address came from the CEO and they'll click the document and certainly then they'll be owned. In this case, the user actually thinks they wrote the document, or at least that they own the document, there's nothing to be suspicious about. We add some macro goodness. I like the Metasploit or MSF encode with the VB script, works wonders. We load the file back on the machine that they can access, and then the file automatically synchronizes. All we have to do is wait for the victim to open the file on the internal network, right? So we could wait. But
ain't nobody got time for that.
Right? And so come back to social engineering. Your social engineering has to be much more likely to succeed because you have tons of background information, right? You already know the file contents. The victim thinks they created the file. It doesn't get any easier than that. If you can't call the victim up / send the victim an email / whatever and get them to open the file, get out of the business, right? There's no social engineering here. I mean, if you can't do this, there's no hope, right? So let's look at some of the commands. I've ended up using a pipe delimiter here because there are no pipes in Windows file names, and that seems to work very well. So we look at basically being able to put a file. In this case, we're going to do a local, the local name is just the name of the file. We don't put any path on it. Ultimately, that's going to be in the Dropbox synchronization folder. In order to make this useful, this is probably a file that you uploaded, right? You probably don't want to move, in this case, put a file that they already had in their synchronization folder. By the way, this automatically deletes the file inside of the Dropbox synchronization folder. So again, in this case, we might say fgdump, for instance. We're very interested in grabbing the user's hashes, maybe for some other follow-on attack. And so you do a put fgdump, and then you might write it to C Windows temp fgdump. So again, it allows you to upload an executable, but there's no actual requirement that you name it that inside the synchronization folder. In fact, that would be really, I don't know, I think that would be forensically bad because the user actually gets a little pop-up bubble every time that a file gets sent with Dropbox. And I'll show you that in a second here. They get a little pop-up bubble, and it'll say something like, new file added, fgdump.exe. Now, Yeah, I'm not that good at this, but I'm pretty sure that the user is going to, at some point start to get suspicious about fgdump.exe. But it turns out that if you name it something like, whatever, reports.doc for the trip through Dropbox, Dropbox doesn't complain at all about the file type being wrong for the file signature. As far as I can tell, they don't even inspect it. And so from a security standpoint, that could certainly be improved upon. But again, you can upload it as reports.doc and then basically say to put it in C, Windows temp, or wherever it is that you like to write files. Bearing in mind, of course, that when we execute the put command, it's executing in the context of the user, right? Because Dropbox is running under the user account, so you can't do anything that the user can't do. Right, so from a writing standpoint, if you're on a good old XP machine, you can probably write to C Windows temp. If you're on a newer machine like a Vista or Windows 7, you're probably going to pop UAC. So that's one of those things that you want to avoid. Of course, we all know that our users are going to click the UAC pop-up anyway. I don't run into many users that don't. But this is ultimately, again, it's going to delete whatever that local file is out of the Dropbox synchronization folder, because the assumption is you don't need it anymore. Right? You put it there, it gets uploaded, and then the put command executes. And so Git is basically just the opposite of that. Again, the remote name, we're going to give it the full path on disk, and then we give it a local name that goes into the synchronization folder. Again, a local name doesn't specify a path. So in this case, it will not delete the file off of, to be very clear, it doesn't delete the file off of the remote system. So this, again, is how we would do some type of exfiltration as opposed to sending commands in. Or if we need to get the output of commands back, we would use a git as well. So exec. Ultimately, it's going to execute a command on the remote machine. And again, this is executed on the user's context, user's account context. We don't want to pop UAC. The command output is not automatically recorded. This is something we played around with. Originally, we were recording all the output. So a command would execute, we would grab all the output and write it to a log file and spit it back into the user's Dropbox folder, and it's synchronized. The problem with that is every time you write a new file, you get another pop-up balloon. And we found out that most of the time, we didn't really care what was coming out from a command, from a command standpoint. If we wanted to redirect something, we would do a git on that file. We would redirect the output to a file and do a git on it after that. From a standard, pen testing piece, you generally try to avoid writing files to the disk in the first place, but since I can't avoid writing files at all here, it doesn't really matter, right? Whether we write it in one location or two locations. And so ultimately that was a design choice that we made. We've got a move command. Again, this is just a utility or a convenience command. It could be done with exec. You could pop a command prompt and certainly make a file move. But we found out that we were wanting to move files around enough that we implemented that separately. Implemented a delete command. Again, just another convenience piece. This could certainly be done with cmd.exe and deleting a file, but it just avoids popping another command prompt. And there are a couple of antiviruses out there that get really squirrely when you start running command prompts from some processes that don't have associated GUIs. Who knew? So then we had sleep. And so this is actually kind of counterintuitive, but again, because every file that's sent by Dropbox creates noise on the target in the form of those pop-ups, we wanted to do whatever we could to minimize the number of times that we had to send files, tasking files, to the user's account. What sleep allows us to do is basically execute a machine survey. We know that the machine survey is going to take some number or some amount of time. Anytime a good adversary gets on your machine in the first place, they're going to survey it and figure out, is this really someplace I want to be? Likewise, again, we're only using this because we can't figure out a way yet to get a standard TCP connection, a solid TCP connection out of the network. In which case, we're definitely going to do some survey to figure out networking setups, basically networking setups, proxies, whatever it is that might be blocking us. What sleep allowed us to do is to send one tasking file, basically where we would do a put to send up our survey binary or survey batch script, whatever the case was, and then wait for it to finish executing. So we would do a sleep, and then we would ultimately grab that back. In one early version, we thought about not needing a sleep, and we said, well, we'll just wait for commands to finish executing. There's an inherent problem here in that we can't ever troubleshoot this, right, until we get on the machine, in which case we don't really need this, right, or on the machine via some other method. And unfortunately, we ran into a couple of misbehaving binaries where there was some problem on the machine, whatever the case was, that program didn't stop executing, and then we lost our command and control. And so it was a bad time was had by all, and so we just decided to implement sleep. So how do you detect this kind of stuff? Well, the IDS at this point is 100% worthless, right? The IDS will not protect you, and that kind of makes sense if you think about it. One, Dropbox is sending everything out via HTTPS, And unless you're inspecting all of your HTTPS or your SSL encrypted connections, then again, what are you going to see in this case? Even if you're looking for executables over the wire or whatever the case is, again, these are encrypted. I don't think the IDS is going to help you. Firewalls, again, mostly worthless, right? However this user is set up, he's already configured to allow, or the administrators have already configured to allow Dropbox out of the network. And so, since you're abusing the fact that Dropbox is already allowed out of the network and to download files over the network, again, what's the firewall going to do at this point? It's very difficult, especially, again, over those encrypted channels, to differentiate your traffic, right? To differentiate your traffic from any other legitimate Dropbox traffic. Is antivirus going to catch us? Come on, right? I mean, what can't you do with anyway, I'll leave that one alone. I don't want to get sued by antivirus vendors on top of Dropbox. But how about DLP software? This is really worthless too. In this case, it's worthless for a whole lot more reasons than just the fact it doesn't protect you from this attack. DLP software in general is trivial to bypass. But think about what we're doing here, right? The DLP software doesn't even get the chance to say, is this file writing, for instance, to a USB drive? Or are we writing this file to a network share? I'm not seeing a whole lot of DLP software out there that's set up where it'll actually detect, or it's checking to see, are we writing to a local directory on the system that happens to be configured by Dropbox to synchronize out to the web. Right? And so that's a challenge that the DLP software has. If it were going to detect this, if it were going to detect, for instance, an Excel file that we're exfiltrating full of social security numbers, right? Or credit card numbers, whatever the case is, the whole idea of what the DLP software is supposed to be designed to detect. Again, the challenge that they're up against is that they're looking for a file being written to a local folder. And again, maybe they're monitoring the default directories, but users can configure others. Again, I don't see DLP software winning this. Whitelisting software, I'll give these guys a win. Ultimately, they're not going to let the new application execute, but certainly we know how to get around whitelisting software. Some of the new PowerShell hacks where they're throwing stuff right into memory, that seems to work pretty well. So, how about next generation firewalls? Because a couple of people questioned me on this that were reviewing some of the slides. I can hear the CISO now. Their shiny next-gen firewall is going to save us from this horror. Well, only sort of, right? And so if your next-gen firewall is set up as a proxy, and you have configured the certificates on all the machines to trust this proxy so that you can do SSL decryption in the middle, maybe this saves you. The reality is, though, that pulled some data where some people looked at next-gen firewalls and who was happy with them, who wasn't. Ultimately, 75% of the respondents in one of their in one of the 2012 surveys said their next-gen firewalls were increasing their workloads. And so this sounds to me a lot like IDS, right? It was a panacea in the 90s. IDS was. I think next-gen firewalls are the new panacea. Basically the way to solve us from all of the horrors out there. At the end of the day, it's down to a black and white decision. Do you allow Dropbox on the network? Replace Dropbox with any of these file synchronization services. Do you allow them on the network? Because, again, it's very difficult. I don't want to say can't. I should have taken that out there. It's very difficult with most of your next-gen firewalls. By the way, buzzword bingo, right? And so to surgically filter that content. So the question really comes down to, do you allow the synchronization software in the first place? Any detection methods that I've come up with are really focusing on finding illicit synchronization software installations. Again, this channel exists by design, right? Again, that's what it's there to do. It's there to synchronize files to and from many machines. The assumption here is we have one machine, we want to ultimately use it as a covert channel. Again, if you allow the software, you implicitly allow the covert channel with it. Right? So I have some detection strategies. Unfortunately, they mostly suck. So Dropbox uses this protocol called LAN sync. This is another thing that got me looking at this. Every pen test that I go out and do over the last 2 years, right? I run a packet trace, run a packet capture, and I've got this crazy Dropbox LAN sync protocol kicking around on corporate networks in places where, and then you go back and you're doing your pen test report, you talk to the security guys and say, oh, cool, you guys use Dropbox for, for, I don't know, collaboration or whatever it's designed for. And they're like, no, we don't use Dropbox. No, that's not installed on our network. And it's like, oh, hey, I hate to break it to you. Dropbox is definitely installed on your network. This LAN sync protocol is beaconing all over the place. And so this is another active area of research for me. It broadcasts on UDP port 17500. The idea here, as I understand it, this isn't phenomenally well documented, but the idea is apparently that if you have two machines on the same network, so picture like mom and pop home network, basically set up where they have multiple machines on the network and they're the same LAN segment, same broadcast domain, and they want to use Dropbox to synchronize. There's no reason, obviously this saves Dropbox money, there's no reason to send the files all the way out to S3 and then have them come back down. It just doesn't make any sense. And so what this LAN sync protocol does, it beacons over UDP 17500 and says, hey, I've got new files for this particular account ID. Again, not using the user's email, just using their, basically just using that unique ID that Dropbox sets up. And it says, hey, do you have a new copy of this file? No? Okay, cool. And then sends it over TCP. And that is actually encrypted when it's sent, but it won't surprise me at all to find out that there's some protocol vulnerabilities. There's some places to play around in there, I guess. So definitely looking for those broadcasts on 17500 is a big win if you're trying to detect this and get it out of your network. You can look for DNS requests to servers related to synchronization servers. This certainly is, it's workable. But realistically, I don't know that this is that's going to be the biggest win either. Blocking access to Amazon S3. So that's the Dropbox backend. I would say about half the file synchronization services out there are directly backed by Amazon S3, and I think the other half probably are backed by S3. It's just not obvious that they are. So Amazon's S3 is their basically their scalable storage solution. And so again, Amazon is very Dropbox is very upfront about the fact that they're backed directly by Amazon S3. If you simply block access to Amazon's S3, either by certificate or by IP ranges, again, you're going to break a lot because S3 is being used for content delivery networks now. That's not really a solution either. It's going to break other stuff. We can look in user profiles for illicit synchronization software installations. So this is really interesting. I think that I'm almost positive in this case that our Dropbox engineers and our Box.net and whoever else out there, the file synchronization guys, realized that UAC was killing them. Right? They realized that when a user wants to use this program and they're not a power user on the machine, that all of a sudden they're not able to install the software. And so they looked around and said, maybe we should write all the binaries into the user's profile because they have write permission there. And so that's what they did. Ultimately, these programs now are installing into the user's profile. Now, mad props to these guys for solving a problem, right? Because now they're retaining customers. But let's be honest here, security professionals, this is pure insanity. What other applications do you allow your users to install on machines into their profile directories that ultimately have some type of back channel command and control or exfiltration? I think the answer is, or at least should be, none. In any case, we can go through, we can scan these user profiles for these software installations. This is something I do regularly with several of my clients, and it's been reasonably successful. I rarely, if ever, go into a network with more than 500 machines, and we don't find 2 or 3 users already using these services. And again, most of the time, management is blissfully unaware of the fact that they're doing it. So, do I have any better detection strategies? Here and there, I'm working on some stuff with Bro IDS right now, but realistically, not right now. Better detection strategies, not really. Again, you're taking the vulnerability with the convenience. If you want the convenience of the software, right, then ultimately you have to take the vulnerability along with it. It's almost like Outlook, right? I mean, I love Outlook, or at least I love email. Backup, I don't really love Outlook, but I do love email. Right? And so, again, it's much like that. If you want email, you're already creating a command and control channel there. It just so happens everybody's looking at it. Right? This is a case where I don't think everybody's looking at yet. Hopefully that changes. But realistically, it's time to talk to management and find out what the policy on these services really should be. Does your acceptable user policy discuss whether or not this is acceptable, right? Most often it says don't install software on the machines. Okay, check, right? We got that. That's awesome, right? But realistically, if the users can do it technically, and they're going to be able to, in this case, unless you have some type of wild whitelisting software like Bit9, they're going to be able to install this because it's writing into their profile directories, right? And executing from their profile directories. Picture now your users with roaming directory or roaming profiles, and again, it's game on, right? So So let's look at a little demo. Hopefully the internet doesn't bomb. Even if it does, that's okay because we have good old LAN sync. So LAN sync will save me. So let's see. Okay. So I've got an XP machine running here. Basically, he's got Dropbox set up there. So one of the neat things with Dropbox is that it will actually allow you to basically log in directly to your account. Note to self, if you're ever registering for, oh, come on, don't do that to me. Let's see, will that maximize? Yeah, good old XSS here. All right. Now, in any case, I was going to go look at the user profile. I can't even get over there. That's cool. We'll see if that comes back. So in any case, you have your default Dropbox synchronization folder. And so the synchronization folder defaults to the My Documents Dropbox in your XP machines, or the application data, or sorry, Documents Dropbox in the Win 7 machines, or Vista and later. And so again, all we're really doing here is we're ultimately running, again, we're going to ultimately execute some code. I don't have Office installed on here, so I basically pre-infected the machine. But if we open up a task manager, as delivered, and this should be on your conference CD as well, as delivered, it's actually running as dropsync.exe. And so it sounds sort of legitimate. It runs with Dropbox, installs into the user profile. So again, it roams just like Dropbox does, and ultimately won't pop UAC when it first lands on the box. So it'll ultimately execute out of wherever you set it up with your macro code, and then it'll copy itself into DropSync in the user's app data folder and set up a run key. You can see it's a very minimal memory footprint. It just works on polling. This is not rocket science, but it happens to be highly effective. So we can see here that we've got, I guess the first thing we'll do is delete a file. And let's see. So we've got a file in here called deleteme.file. And so what we'll do is we'll come back over to our, let's see. Yeah. And so what I've got are several test files in this case. And so basically this is all it takes, is essentially to say I've got a file and I say delete deleteme.file. And so this ultimately, as we move this in, what the key here is this little dropsmack underscore. So when you build the binary, and again the source code's included so you can rebuild the binary, because I'm sure tomorrow or within the hour you won't be able to synchronize files on Dropbox that begin with the term dropsmack underscore anything. I think the Dropbox guys are really smart and they'll fix that right away. I hope the Dropbox guys fix that right away, right? But in any case, for right now, hopefully this still works. And so, again, basically all you're doing is setting up to delete the file. And so if we copy this into the Dropbox folder on, picture again that this is the actual machine that you have control of. So the laptop at home, bypassing the corporate defenses. And so what's going to happen here ultimately is that gets synchronized to the cloud. You can see the little green checkbox. I don't think it really synchronized that quick. I think what you're seeing is the ultimately, and there we go. So now we have the pop-up. And notice you've got pop-ups on two different machines. First, you have a pop-up on your, if you want to call it your bastion host, the machine that, luckily the pop-up goes away, which I think is really cool. I appreciate that from a Dropbox developer standpoint, that the pop-up doesn't stay up there, because that could be hazardous from a pen testing standpoint. But as we've used this with pen testing, I found that it's highly effective, or most effective at least, to condition the user to see the same file name pop up again and again and again and again. And so when I'm sending a file over, I use the same file name, usually something .xls, and when we're pulling exfil data back, it's the same file name, .xls. And so the user just gets conditioned to seeing that damn file again and again and again, whatever that happens to be, whether it's TPS reports or whatever the case is. And so ultimately then that command gets picked up on the other side here. We can see here on the XP side that for whatever reason the pop-ups are actually staying up there. That's awesome. But in any case, that deleteme.file is now gone from the C drive. So we've got a good delete set up. Likewise, we can set up to do, let's see, what's in the exec? So exec, if we wanted to run calc, for instance, on the target, you would never really want to run calc, but that's cool. And so we set up, and then calc will start over on the target in a second. Yep, so it notices that it was added. Again, you want to pick a smart name in this case, right? We're polling for some type of name in this, and so then calc starts up in the background. This could just as easily be FGDump or whatever it is that you need to do from a survey standpoint. Again, you want to pick smart names here for your exfiltration files, for infiltration files, even specifically the command files, right? DropSmack underscore whatever just doesn't sound right. So if you've got a company that you're pen testing, for instance, Massive Dynamic, right? Certainly Massive Dynamic underscore something wouldn't be a bad place to start. Because again, what DropSync is going to do, or DropSmack, on the other side, it's going to look for that file name and then parse that as if it were command text. So what else can we do with this? Well, we'll close out calc. And so we've got a survey that we looked at doing, and so this is kind of what we've done in the past. Seems to work very well. Just get some configuration information just using a batch script. And so, yep, thanks, got that. We deleted. And so what we're going to do here in this case is take that projections.xls, and again, that's the file that, just a good file name that we like to use. We're going to send it up to the c:survey.bat. We're going to execute it, sleep for 10 seconds because it takes a couple of seconds to execute. Then we're going to delete it on the other side. Yeah, I could delete the batch script from inside the batch script, but whatever. And then in this case, then we'll do a get on the temp.txt, the output file from the survey. We'll ultimately call it projections.xls, because now again, picture this user is seeing the survey come over as projections.xls, and then when the pop-up comes up again, he sees exactly the same file name. Again, people are creatures of habit. I want to condition this person, whoever our target is, to seeing the same thing again and again. If the user's not in front of his machine, I really don't care, because as you can see, sometimes the bubbles go away, sometimes they don't. Even if you come in at the end of the day and those files are no longer there, you're not really looking at a whole lot. And then ultimately, don't forget with the get, right? Because we don't want to, for exfiltration, anytime we exfil a file, we don't want to automatically delete it. If you created a temp file, you want to pick that back up and delete it. You don't want to leave it there for forensic analysis later, if you can avoid it. So, although we'll talk a little bit about forensics in just a minute. So I'll put that in the survey folder. Oh, that's right. So I should put projections.xls in there first. Let's see if we edit this with, yeah. And so in this case, you can see this is just a very, very, I mean, it's not even a real survey, but rock on. So we want to put that into the target folder first. Yeah. Okay, so again, that's going to automatically synchronize. If the user tries to open it, obviously it's not going to work. That works in our favor, actually. Looks kind of like a corrupted file. Obviously, again, this isn't withstanding any forensics or any of that, but at the point somebody's doing forensics, you're already screwed anyway. So we send the survey command over, and you can see here that the survey command was added. Here's our Dropbox synchronization folder. And if Joe, whoever it is, happens to be looking at right at this time, yeah, that's bad. And again, we've got the pop-up coming in there. But again, that's why you want to use better file names. One of the things that occurred to us as time was going on was that it wasn't really bright to have to always use text files. And so area of future research, and we thought about releasing it here, and then the lawyers advised us not to release this here, but was to start parsing, for instance, maybe .docs or .pdfs, looking for real PDFs, well-formed PDFs or well-formed documents, looking for the command. So basically embedding these in other file types. I can tell you today that you can place a fake file header on a particular command file. For instance, just the magic number for .doc and name it a .doc, and then you can run the file command against it. It just won't open. And so that's doable today with the code that's here. Some of the rationale from the lawyers was that as you start getting more and more stealthy with this, it stops looking like a pen testing tool and starts looking like malware, and you don't want to be the guy that released malware into the ecosystem for use in Dropbox because they will probably sue you. I said, cool, that sounds like a good plan. That's why you get paid the big bucks. So I ultimately have this projections.xls. This doesn't automatically do anything except synchronize to the cloud. Now, if you happen to get the guy's cloud, basically his cloud password here for whatever reason, be it a keylogger, be it because you stole his database and you reverse engineered how Dropbox stores those credentials, whatever the case is, you're able to come and not have to control the laptop anymore. This is kind of a key point here, is that if you're able to grab these credentials, and you can in almost every service but Dropbox, as in it's trivially easy in almost every service but backup. Every service that I evaluated, except for Dropbox, did not encrypt their databases. They hashed a password oftentimes not even hashing it, it was encoded in some way, so you could actually get the plain text password back. But it turns out that as long as you had the hash, it didn't really matter. Again, these are all basically set up so that it's for user convenience. So the user can click the little thing on the side, the little icon that for whatever reason is off the screen at this point, but he can click the icon on the side of the screen there and say, go to Dropbox on the web, and it automatically opens the web browser and logs him in. So again, picture the point that you've done this, you no longer need control of that laptop because you have the web, right? At this point, we can download projections.xls or any of our exfiltration traffic from their HTTP interface. Again, almost every major provider implements this as well. This isn't unique to Dropbox. So as well, we can send our tasking files this way. But one of the things from a forensic standpoint that I wanted to point out is, show deleted files. Awesome. And so one of the problems that you run into here, and this is one of the reasons that I would suggest if you're going to do this as an APT guy, as opposed to if you're pen testing, nobody cares, right? After you issue the pen test report, you say, and this is how we got in. Oh, by the way, you're almost certainly, I feel obligated to say this, you're almost certainly violating Dropbox's terms of service by doing this. So depending on where you sit in the good old Computer Fraud and Abuse Act land where violating terms of service is actually a crime, just be aware. So, yeah, crazy. So in any case, you can see that your files are still here. There is an option somehow off the screen here, even though I have this maximized, to delete those, ultimately to delete those files permanently. That's great. It turns out the Dropbox still will have kept a log, which is one of the reasons that you want to keep these files named something appropriate. So even after you delete the files here, even though you won't be able to pull the file back anymore for inspection, from a forensic standpoint, one of your high-speed forensicators can still come in and identify the fact that there's basically that these file names have been in play. And so if you uploaded something as fgdump.exe, it wouldn't be very stealthy. But if you happen to have done that, then again, that's going to be sitting in the Dropbox folder for anyone to see. So if we take a look at our exfiltration, we would do something like, I don't know, rename this to something.txt. We'd probably move it out of the folder before we did that too, but that's cool. Okay, and so again, you can see here that we've outputted, or ultimately output information from whatever our survey information was. I think in this case we did an IP config and tried to get out to Google and a couple of other little minor directory walks. So again, just from a concept standpoint, this isn't rocket science. It works very well. It's saved my butt in at least one pen test up to this point. And again, that's ultimately where the idea came from, is looking at and seeing that we had a user that was using Dropbox and said, okay, now what can we do? And so again, I'm positive this idea is an original. I thought that it was. Then I went and I found that Usenix paper as I was doing some cloud research. And so my assertion is that there's already people doing this. So I don't think I'm releasing, I mean, maybe the fact that I'm bringing it up at Black Hat, I don't know. I haven't seen any adversaries doing this yet. I don't have any evidence that there's, or any forensic evidence that there's malware out there that's synchronizing using these services, but I bet the money in my pocket that it's already happening. And if it wasn't before today, I can almost guarantee you by tomorrow somebody's going to, somebody will do it. So future work. We really need to be able to read and extract the information from the Dropbox configs. I have two key problems at this point. One, I don't know where the user set of synchronization folders up. So I guess at this point, because every time I've reverse engineered these things, obviously for security purposes, because anything else would be a violation of the DMCA, so every time, they're changing these constantly. The Dropbox team, again, kudos to these guys for the code obfuscation that they're doing and for encrypting their databases. We just assume a default synchronization folder. So far it's worked, and I've never seen a user turn that off. I've seen users add extra folders, but I've never seen somebody turn off the default Dropbox folder. So if somebody happens to do that, that breaks this version of DropSmack explicitly. So if you're looking for a security fix and you feel like you need Dropbox, go and delete this folder immediately, right? And have your users synchronized from some other folder and you're set. It doesn't work. These pop-up notifications are a giant pain in the butt, right? I don't particularly appreciate these. Users probably do. If you were going to use this as a solid, command and control channel for some extended period of time, I would really, really, really want to get rid of these. So need to find some kind of strategy to get rid of these pop-ups. We're creating a lot of them, right? The sleep command helps us create a few less of these ultimately, but still, we're creating a lot of them. So. Ultimately, other future work, right? So we want to build proof of concept. I meant to change that. I didn't mean malware. What I really meant were proof of concept pen testing tools, right? Make a note, don't want to get sued again, right? But that you're using other synchronization services because Dropbox users shouldn't feel all the pain, right? What I don't want to happen here is somebody says, oh my God, the sky's falling because Dropbox is insecure, I'll move over to service X or service Y. You know, the reality is, again, they're every bit as insecure, actually more so, because I haven't found another vendor yet that's encrypting their databases on the drive. Right? So they're not using these encrypted databases, the SQLite databases. It takes away the challenges we have with Dropbox. Right? So again, to review those challenges, one is finding that synchronization folder. I got no problem with any other service because that configuration information is stored either in a plain text file, which I think is laughable, or like an INI file back from the 80s, right? And so either that or it's sitting in a SQLite database, which again is easy to read with any tool. And so we don't have to worry about where that synchronization folder is. Likewise, we can pull out the hashed creds so we can immediately pull that other machine out of the loop. Right? Again, that laptop sitting at home, we can just use the web UI from then on, and that's awesome. So note to vendors, if you happen to be a vendor for a synchronization service, encrypt your databases because it makes my job phenomenally harder. Other things we're looking at, so extracting login information from the web front ends, from the client-side databases. Likely either Black Hat or DEF CON will be releasing some code that does this in the form of post-exploitation modules for Metasploit going in, and that way if you've got one of these databases that ultimately we'll have worked out how to rip the creds out of at least the top tier vendors. Again, if we can get credentials some other way, like the user logging in, that would be awesome, maybe with a keylogger or something. But the reality is that Dropbox and the ilk, they make it very easy for the user. The user enters the credentials once when they set the program up, and then they never have to type them in again. So once the user manually opened up the browser, surfed over to the site, and typed in his password, that would be the only time that would be of any consequence. One of the things that's really, really interesting, though, is if you log in, we figured out that if you log in and you create your account, essentially, so let's say that I'm using a super insecure password like ABC123, as my password, or something like password, whatever the case is. And so Dropbox on my machine now is using password, or whatever that is, as the password. And so down the road, some security guy comes to me and says, hey, that is a really stupid password, you should fix that. And I go and fix it. It doesn't invalidate those machines that are already set up to synchronize. You would think then that you would have to go re-enter your password on these other synchronization machines, or these other machines that are set to use password as a password, but it turns out that's not at all the case. And so, at least it isn't today. I hope that change gets made tomorrow, because again, this is a horribly insecure setup. Again, I'm sure you can picture some of the evil ramifications of that, but ultimately extracting this login information so that we can totally cut out whatever this bastion host is. Again, it's an active area of research for us. We expect to release some code later this year on it. So what's the conclusion? Well, this isn't rocket science, right? Anybody could have written it. If you're a pen tester that finds this useful, I'm glad I could be of help. The real point here is I want to demonstrate the vulnerability that this is real. I mean, these file synchronization applications create a real vulnerability in your network. Not because they have bad code and they're going to get exploited with some buffer overflow, although I think that's certainly possible as well. Again, just because they're creating that backdoor, basically a command and control channel. If you're comfortable with the vulnerability, rock on. Forget I ever gave this talk, right? If you're not comfortable with the vulnerability, if you think, wow, this is insane that I have this channel that's not being protected by DLP, it's probably not being protected by my firewall, right? And Jake just showed me how to issue command and control and release binaries on DVD, then this is a conversation you should be having with your security team, or you may be your security team. I don't know, make it, have the conversation with the, with the CFO or whoever it is that makes those decisions. But again, this really started out as a project to basically help our clients make an informed decision about risk. Right? We looked at this when we were doing the cloud forensics course and said, holy goodness, I can't believe this stuff actually works this way. And then people just naysay. They said, oh no, nobody would ever, you bring up a conceptual idea and everybody says, no, nobody would ever do that, that's crazy. Right? And so we built this, ultimately used it on pen test. That was awesome too. But really the idea was that we were trying to educate our clients about the risks that it presents. So again, Black Hat would really appreciate it if you do feedback surveys. And thank you for your time and attention. I'll be happy to answer any questions you guys have. Thanks.